Hey class, so today I come back with section 7.6 rational equation and formulas. Um, so let's start with what is a rational equation? Okay, so rational equation. Um, and I want to make sure everyone understand what's the difference between rational expression and rational equation. Expression. So rational equation, let's have an example such as 1 over 10 minus x equal to 1 half. And then what's the rational expression? I'm going to say 1 over 10x, 10 minus x. So if you take a look at both of these and tell me what is different between rational equation and rational expression, you can see that the rational equation is having a equal sign, right? That's a nice called equation, right? Equal, right? Um, and for the rational expression, it just have one fraction, one rational term, right? Um, yeah. So it and it doesn't have any equal in here. So that's the difference between the rational equation and rational expression. Um, and we also need um, to know that um, in order to solve uh, to solve I'm just gonna say solving uh, um, they have another definition. Let's say basics rational equation. Okay. Basic rational equation is the equation that have in the form as a over b equal to c over d. So this is just basic rational equation. So for solving basic rational equation, what we have to do, we have a or b equal to c over d as a basic rational equation, and um, and then we can just using the cross multiplying cross multiplying uh, such as a d equal to c times b or b times c. So that's b times c. So a times d cross equal to b. Let's see. So you can keep in mind that, note that b and d are non-zero. Okay. So let's move up. Example 1. A. Let's do an example. So we have solve let's solve x plus 1 divided by 5 equal to 3x over 2, right? So what you do is you're gonna using cross multiply, right? So x plus 1. Remember that you should have the parentheses first, so then you don't miss that, right? Multiply by 2, right? Because the cost, right? Cost equal to 5 times 3x. Okay. Now what? I need to do distributive. I need to use distributive properties. So x times 2 will be 2x plus 1 times 2 gonna be 2, right? And then you have 5 times 3x gonna be 15x. Why I can use cross multiply? I know that because the bottom are 5 and 2, right? Which is not equal to 0. They both not equal to 0. So now what is next? You have you have both hand side that also have the variable, right? You have the left hand side have 2x, the right hand side have 15x. What should you do is you're just going to subtract both hand side by 2x. So subtract both hand side by 2x. Let's say we have 2x here, minus 2x here. And then you will have 2 in the left hand side, and the right side is equal to 13x. So easily you can just divide by 13 both hand side, and the final answer should be x equal to 2 13 for the this solution of this what's it called, of this basic rational equation. Okay. Let me move down. So that have B. Let's say you have x equal to 4 times 3x minus 4. Okay. What should I do for this one? I actually can I firstly will have a dependency for this one, right? And then I can convert the left hand side to be come a fraction form as x over 1 equal to 4 over 3x minus 4. Okay. So now I can apply for the cross multiply, to solve this one and make sure the bottom not equal to 0. So I want to have note that the left denominator will be equal to 1, but so that not equal to 0. But 3x minus 4, how to make it not equal to 0? you need to have x not equal to 4 over 3. You add 4 both inside and divide by 3 both inside. Then you have then you have x not equal to 4 or 3. So later on, if the solution is equal to 4 or 3, which is not satisfied for this requirement. Okay, so let's move to the cross multiply. I have x multiplied by 3x minus 4 equal to 1 times 4. Now, distributive properties, you're going to have 3x squared minus 4x equal to 4. So this look like quadratic form, quadratic equation. You can actually subtract both inside by 4, or you move this 4 from the right hand side to the left hand side. You have 3x squared minus 4x minus 4 equal to 0. So you will have to think about to solve this trinomial equation type number 2, because you have a equal to 3 in here, right? So you have a equal to 3, b equal to -4, c equal to -4, and so using the grouping method by having by trying to find two numbers that multiply equal to 8 and c with equal to 3 times -4, and that equal to -12, and b is equal to -4 is going to be the addition of the two numbers. So two numbers multiply equal to -12 and addition equal to -4. What is that? What I say? So I would say 2 and 6. Let me see, -2. No, +2 and -6 better, right? Because that addition is going to be equal to -4. And now I will convert it to become 3x squared plus 2x minus 6x minus 4 equals 0. This plus 2x and minus 6x is come from the -4x. Okay. Now you're gonna using grouping. You're gonna use grouping method. So factor the greatest common factor between the first two term is gonna be x, right? And 3x plus 2. The next two term will give you greatest common factor gonna be -3, no, -2 actually. And then the first term give you 3x, second one is plus 2, that equals 0. And you factor it, gonna be x minus 2 times, no, let's just factor the greatest common factor first. So 3x plus 2 multiplied by x minus 2. See that? Because you have, when you look globally, you will see that you are having a common factor as a group, which is 3x plus 2 and 3x plus 2 over here, right? So then when you factor it, you're going to have x minus 2 as the last two term. Okay, so equals 0. So apply the 0 probability, you have 3x plus 2 equal to 0, or x minus 2 equals 0. And then you will have x equal to -2/3, or x equal to 2. These are the solution So you're going to make sure, are they equal to 4 thirds? No. So they are all going to be satisfy the solution. Okay. Okay, so let's move. Let me see if we I have another problem. Let's have what the last one? B. Okay, now let's have another one. C. If I have 1 over x plus 2 over x equals to 3 over 7, all right? In order to use cross multiply method, right, you need to have both sign with only single fraction, right? So in the left side right now, you have 2 fractions. So you need to combine it to become only one single fraction. So in order to do that, you need to make sure they are in the same denominator. And as you see here, they are in the same denominator. So you can add them to be 1 plus 2 over x equals 3 over 7. So do operation on top, keep the bottom, right? And then, so now you have 3 over x equal to 3 over 7. So in this case, actually, if you see that, you quickly understand, you can see that the top right now are both inside, both of them are equal to 3. So it's supposed to be, the bottom is supposed to be also equal each other. So that means you can right away say x equals 7. Other than that, you can apply the cross multiply for this case also. So it can rewrite as 3 times 7 equal to x times 3, right? And then you're gonna have 21 equal to 3x. And you divide by 3 both inside, you will get x x equal to 7. So exactly what I just say, right? But yeah, just keep in mind that you can also apply the cross multiply in this case. And again, you have to note that x cannot equal to 0 since x was in a denominator at the first the left term, right? But in here, the solution was 7, so it's good, satisfied. So now we move to another method we call solving rational equation by multiply. Multiplying xi by the LCD. Okay. Let's try an example. 2. I have a as 1 over x minus 1 minus 1 over x here equal to 1 over 9x. What we had to do is we had to find the LCD first. Find LCD of x minus 1, x, and 9x. So if you want to use the listing method, you have x minus 1, you have x here, and you have 9. You have 9x with x from 9. Right? You're going to factor it. So when you find the LCD, it's gonna just be equal to so x minus 1 put down, right? Because there's no one in common. X with x here, so put down, and then 9, right? So rewrite is I can rewrite as 9 times x minus 1 times x. So it is LCD. So now what I should do is I'm gonna multiply by the LCD with all the the term in the equation. So I'm gonna say multiply each term by the LCD 9x minus 1 times x. So now what I have 1 times x minus 1 over here, right? I minus with 1 over x, right? And then equal to 1 over 9x, right? Okay, so I would like to multiply by the LCD, which is 9 times x minus 1 times x. And sorry, times 9 x minus 1 times x, right? Because I multiply both sides, so then they didn't change the equation at all. Okay, both sides of it. So now what happened? I can just cancel the common denominator, sorry, common factor between bottom, top and bottom. Sorry, this one doesn't have. This one have x. This one have 9x, 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 right? So I will have 1 times x times 9, which is 9x. For the first term, I minus with the second one is 1 times 9, which is 9 times x minus 1. And last term will be x minus 1. Okay. So now I need to do distribution to open this parenthesis, right? So I have 9x minus 9x. Remember that I have negative 9, right? Negative 9 times x is going to be negative 9. Negative 9 times negative 1, right? Going to be equal to positive 9. So remember that I also have a negative here, right? Equal to x minus 1. So now if you see that we have a 9x and positive negative 9x here, that's going to cancel. And now you can just add both inside by 1 to cancel this number 1, and then you have x should be equal to 8 as answer. You can also note that because you have the bottom with those numerator, you have to have x not equal to 1. Note for the first numerator, and then x not equal to 0 for the second and third, right? But x equal to 8, let me see, wait a second, I should add 10, add 1, so it should be 10 right here. Sometime I make a mistake, right? So x equal to 10 should be a good solution because it's not equal to 1, not equal to 0. Okay, so what about we're gonna try to have one more example for this. So 1 of x minus 1 plus 1 over x plus 1. And then equal to 12 times x squared minus 1. Okay, so I'm gonna First thing, I'm gonna find the LCD of all the denominator in here. LCD of x minus 1, x plus 1, and x squared minus 1. So I can rewrite x minus 1 here. X plus 1, they are not equal, they are not the same, right? And x squared minus 1, remember that x squared minus 1, let me write x squared minus 1, can be rewrite as x minus, where is it? Can be rewrite as x squared minus x, 1 square. So that is different between square. So it is x, we can be factor as x minus 1 times x plus 1. So the LCD should be x minus 1 times x plus 1, or x squared minus 1. It's the same, but yeah, I just want to keep this factor. So I will multiply each term by LCD, right? I need to, come on. Oh. Okay. Yep. So now I'm gonna say multiply each term by the LCD, which is x minus 1 and x plus 1. Change. So what do I have? I have 1 over x minus 1 plus 1 over x plus 1 equal to let me rewrite it to have more space, plus 1 over x plus 1 and equal to 12 over x squared minus x squared minus 1 squared can be rewrite as x minus 1 times x plus 1. So if I multiply both inside by, you know what? I'm gonna move this number 1 to be here and here, right? And then I multiply with the LCD, x minus 1, x plus 1, x minus 1, x plus 1, and then x minus 1, x plus 1. So you can cancel x minus 1 for the first term, x plus 1 for the second one, and both x minus 1 and x plus 1 for the last term. And now you're going to have 1 times x plus 1 plus, actually there's 1 time, this is going to just it. So x plus 1 plus with x minus 1. Okay, so I can, I can just keep the parenthesis here and later open it. And the right side going to be 12, right? So now you open the parenthesis because there is no subtraction between two these parentheses. So you're going to have just say x plus 1 plus x minus 1. So you can cancel this positive and negative 1 later, equal to 12, and the left hand side now become 2x, right, equal to 12. So then you have x equal to 6 as the answer. Make sure, note that x cannot equal to positive or negative 1 because the bottom is not equal to 0. Okay, and x equals 6 is 35, so that's good. Okay, so now let's move. Okay, so I would like to have the step for solving a rational equation. Okay, so this plural. So step 1, I have find the LCD of the term in the equation. Find the LCD of the term in the equation. Right? Well, you need to find the LCD. Okay. Second step, or step 2, you're gonna multiply both sides or each side by LCD. And then comes step number 3, simplify each term. Step 4, you will solve the result equation. Solve equation. And then if you want to do step number 5, it is like optional. Is double check the answer or check the answer. Check the answer by substitute back the source solution, and then yeah. But anyway, usually you have to check if it's satisfied for the requirement. Actually, I would say it's not an optional. You should actually check the answer because sometimes it could make it undefined. So it should be a requirement for the solving. So now let's try a special case. Let's say example 3. Okay, let's solve 1 over x minus 2 plus 1 over x plus 2 and equal to 4 of x squared minus 4. Okay, I can actually want to note that because I have 3 denominator here, so that's going to give me x minus 2 not equal to 0, will give me x not equal to 2. Second one you're going to give me x not equal to negative 2, and the third one can be can be rewrite as x minus 2 times x plus 2. We also gonna require that x not equal to 2 of negative 2. So now let's find the LCD. x minus 2 comma x plus 2 and x squared minus 4. Okay, so remember that the step 1 is find LCD, right? Okay, now for x minus 2, I put it down here, and x plus 2 here. Now for the x squared minus 4, right? Which is x squared. You can rewrite as x minus 2 times x plus 2, because this is actually x squared minus 2 squared, right? So the LCD should be, put down this, give me x minus 2 times x plus 2. Okay. And now you will have what? LCD has x minus 2 and x plus 2. Now move to the step number 2, which is multiply x side by LCD, which is x minus 2, x plus 2. So now you have 1 over x minus 2 plus 1 over x plus 2 equal to 4 times over x squared minus 4, right? And I want to multiply both sides by x minus 2, x plus 2, x minus 2, x plus 2, x minus 2, x plus 2. So you can actually cancel the first term with x minus 2, the bottom with x plus 2. The third one gonna be both x minus 2 and x plus 2, because it's gonna equal x squared minus 4. And now left side give me x plus 2 plus x minus 2, and the right side give me only 4. So this can cancel the 2, and you have 2x equal to 4. And finally you have x equal to 2 by divide both side by 2. But look, this is not satisfied. Not satisfied with x not equal to 2, right? Because that's gonna make and it makes the equation undefined. Okay, so no solution. Okay, because you remember that no solution mean there's no way to solve it. Okay, so this should be the answer. Okay. So for this solving rational equation is actually, we have some application with some problems such as we go out. All right. such as finding time in a distance problem. Distance problem. So let's do an example. Remember that. Oh wait. By following the formula, D equals to R times T, right? So, up, so width D is distance. R is speed, stand for speed. Right. And T is time. So let's do an example. 6A. How far does a person travel in 2 hours with speed at 60 miles per hour? So you can just apply the formula such as distance equal to R times T. And then substitute. In this case, you can actually know that T is 2 hours, right? And speed, which is R, equal to 60 miles per hour. Okay, so then D in here gonna be equal to R, which is 60 times T equal to 2. That's gonna be giving 120 miles. Right. Okay. So the distance is 120. So B, what happened in my pen? B, how long does it take a person to go 250 miles when traveling at 40 miles per hour? So that means what I am having the distance D equal to 250 miles and the rate equal to 40 miles per hour. So I can substitute into the form and that's going to give me 250 equal to 40 times t, right? Remember that d was 250, r was 40, so I just substituted. And now in order to find t, you just divide by 40 both hand side. So then you have t equal to 25 out of 4, which can be rewritten as 6.25 hours. Okay. So I would like to stop this section here. And I would like to see you next time in the next session. Okay.